All right, perfect. So I see you're kind of wrapping up your conversations and appreciate it. And I really do appreciate you coming in right after lunch, kind of getting started. Some of you guys came in early, which I'm fine with. I'm going to be finishing lunch, but you're free to come in a little early if you wish. Let's start with Model 3 for a moment. And I know we did talk a little bit about Model 2, but this one's an interesting one because it's stuff that you actually deal with every day in life. Like, who's ever rubbing alcohol on their hand or on like a wound? Okay, it's supposed to clean a wound. Well, rubbing alcohol is isopropyl alcohol, also known as propanol. Who's ever heard of, like, alcoholic beverages? They're out there. We don't really engage with them, but they're out there. They have ethanol in them. Ethanol is C2H, or this is the formula, C2H5OH is another way of writing that formula out. Who has ever dealt with like a butane lighter? Okay, a butane lighter is like a big lighter. Not that you're smoking cigarettes, but if you like a light a cigarette with it. The little flick lighters. That's butane, which is a flammable gas or a flammable liquid when it's in its liquid form. But butanol is a derivative of that. So what's one thing in common that you guys are seeing? And just shout it out. What's one thing in common in all of these alcohols?
No.
The all ending, that's one. The OL ending means that there is actually an OH attachment on there. That's actually what that means. What else do you guys see?
They all have carbon.
They all have carbon, and then also what else do you see?
Get more specific about that. They all have CH3.
Right, so they all have C and H. It's actually a chain of carbons, and along that they have H's, like their partners in crime. So there's C's and H's all attached, and at the very end there's an OH. So that's some commonalities or similarities you saw. But somebody raise their hand now and tell me the differences they're seeing here. Jacob, you got in here late. Sorry, dude. Tell me what's different between all these.
They're different lengths.
Right, so they have different number of carbons, which then give them a different length of their carbon chain. This should look like a fatty acid that you learned about in biology, of those biomolecules. That's kind of what that looks like. So that's the difference. So when I change the number of carbons, or the alcohol in this case, what is then changing because of that? Evan? Yes, okay.
Boiling point.
Right, so the boiling point over here is changing at a constant pressure and a constant volume, right? So these two variables here are called constants because they are not changing. They're not like a controlled substance. It's not like I'm controlling against another experiment. It's just a controlled variable so that I don't have that influencing my end result, which I'm looking at boiling point in this case. So that's kind of what you're looking for here, and that answers a couple of the questions. So let's compare this model in number 11, where you had to identify the independent variable and dependent variable between the two. So here, this is like a quick review of the scientific method and some important pieces. Back in Model 1 and 2, we dealt with the Alka-Seltzer and vinegar. I'm going to use my cards, so I'm still working here. Serena? No, this is not like this class. Grant, tell me what was the independent variable of that first model with like the Alka-Seltzer and vinegar?
The number of tablets.
Right, so when I changed the number of tablets, that was the independent variable. What changed because of that? What was the dependent variable with that?
The final temperature.
Right, so the temperature dropped even lower and lower and lower as I had more and more and more tablets. So the change in temperature was the overall outcome you're looking at. And then also within that, I'm going to ask your partner, hold on. Sorry, William. Tell me what the control variables were there in that particular experiment.
The volume of vinegar and the initial temperature.
Good. And I think pressure, right, was that another variable that was constant? Okay. So initial temperature, pressure, and volume of vinegar. All right, so that's a good idea of how we can set an experiment with control for everything by changing one variable and measuring another. Everything else the same. All right, and then we kind of went through the basics of the boiling point one, but we'll just make sure we're good here. Name cards. Hey, Callie, can you tell me about the independent variable of the boiling point one?
The number of carbons.
Right, carbons in the given alcohol. So basically, we change the alcohol type to then derive some sort of difference in measurement. And then Cam, what about the dependent? No, we're on the second one.
Boiling point.
Okay, so we saw a change in boiling point. And then what were the constants in that Zane?
Volume of alcohol and room pressure.
Good, so volume of the alcohol and room pressure. Okay, So, as you guys can see, designing experiments can actually be quite easy if you remember that you control for every variable, control for the experiment by changing one variable and measuring something else. Eventually, you guys will be designing your own experiments, and you'll be doing this as like more of a long-term project. So, maybe like a month or so, we'll kind of dive back into that talk. So, I'm going to pause on this for now. We have like 5 to 10 minutes of notes to take on what is chemistry, and then later on, you guys can see the agenda here. So like what is chem is our initial thought for the day, just to get you oriented into chemistry a little bit more. We're going to do a lab safety activity in groups at the lab stations, which doesn't require glasses or closed-toed shoes. It's just a paper activity to get you accustomed to safety protocols that we have to follow. It's a little different than biology. And at the end, I'm going to have you guys make sure that you sign up for something on my website. Okay? So we'll be using the laptops today. So if you want to pull out something to take notes on, we shouldn't be up here too long. And I'm going to keep the lights like they are right now, unless it's just horrible and you can't see something. After lunch, sleepiness tends to set in. It's out now, so make sure you're good. And this actually is correlating with chapter 1 in your textbook. I usually actually start with the hardest stuff in the unit first, and I end with the easier stuff. Why would that make sense? Say again?
Get the hard stuff out of the way.
Well, you get the hard stuff out of the way, and it gives you more time to learn it, right? You start practicing the harder things early, and then we move into like the easier stuff, so it kind of is a nice ending to the unit. But actually, this stuff's just a quick intro. I'll be doing the mathematics stuff, so you'll start some tonight. We'll do the rest of it tomorrow, and I find that to be the more difficult stuff. So, just in generically, what is chemistry? We're talking about matter. And we're talking about the changes that we can make to matter. The changes, another word for that is transformation. So the study of matter and its transformation. And some reasons that we'd be looking into that is because we basically abuse science to do what we need it to do. If I want to be able to cook something in a quick fashion, I'm going to use a pressure cooker. Well, that's a change. I'm pressurizing a substance to make it cook faster. If I want to utilize a high-efficiency gasoline to go farther distance, I'm going to modify the analytical composition of some gasoline to allow my car to use it more efficiently. So we abuse chemistry all the time to make what we need it to make and to make our lives better. So this is an example of matter, what it's consisting of. You can see this example here. It says HHO. What is it supposed to spell out for us? HHO, which together could make H2O. That's a subscript of 2. That's water, right? And that would be a great thing to drink. But what if I had H2O2? That's hydrogen peroxide, actually. You could rub it on a wound, but it's also toxic to the digestive system. So that's like a matter, compositional matter idea. And this over here is representing the changes that could take place to matter. So we're taking liquid water and we're changing it into solid water. What's that process called? Liquid going to solid. Solidification is actually correct, but freezing is the more appropriate term if we're specifically talking about solidification. So, and then this is a chemical change happening. This is a physical change because we're talking about a physical property of a substance. This one down here is like a Mickey Mouse ear. That's water, and that's H2O. And this one over here with 2 of the oxygens here is H2O2. So I've changed the composition of matter, but still, yeah, that is still a chemical change. We'll get more in depth in the chemical changes later. So there are 5 branches of chemistry. I'll start with these 1, 2, 3 right here. That says organic chemistry. Now, in biology, you guys talk about organic molecules or biological biomolecules. Those were all actually organic substances. And in chemistry, organic does not mean like fertilizer-free and pesticide-free, like at the grocery store. It means something else. What does it mean? It contains carbon, and that's it. It can contain a lot of other things, hydrogens and oxygens and sulfurs and nitrogens. But if you contain carbon, we're going to call you an organic compound. So carbon is the key word there. The only thing that's actually not organic, yet it contains carbon, is what you're breathing out right now, which is carbon dioxide. That's actually not organic. It's a gas that we classify outside of that organic category. So by nature of I can read words and know how prefixes work, if organic chemistry contains carbon, or organic compounds contain carbon, inorganic means, right, there's an absence of carbon. So no carbon in the compound. CMPD means compound, not Charlotte Mecklenburg Police Department. So that's just our abbreviated way. So some examples that you really can't quite see here, but would be something like this. Dinitrogen monoxide. Ooh, what's this? NaCl, what's that? Table salt, also known as, it's got a first name and a last name. Sodium chloride, maybe some things are coming back to you. There's other things like, ooh, what's laughing gas? Oh no, that's laughing gas. Who's ever had their wisdom teeth taken out? Okay, me too. Okay, who's ever been put under at the dentist office? Okay, we're the only ones. Okay, you guys will soon be in the cool club, but they give you laughing gas and it makes you feel loopy as anything, but that's it right there, dinitrogen monoxide. And yeah, you have some weird thoughts. And my mom she gave me a smoothie or something afterwards. You're not supposed to like suck on straws because it'll eliminate some of the blood from your wisdom teeth holes. And she just let me drool all over myself in Hardee's. And I was like, Mom, that's embarrassing. Okay, so organic and inorganic are quite easy. They're basically opposites. Biochemistry, bio, what's that prefix mean? Life. So it's talking about just the chemistry within life. And life is not just us humans and other animals. It's also microbes, it's also plants. So photosynthesis and cellular respiration could be two processes that are categorized under biochemistry. So within you right now, you've got digestion happening, breaking down big biomolecules into smaller usable parts. That's digestion. You've got muscle contractions, making sure that you can control micro and macro movements of your hand. Those are all driven by enzymes and other biomolecules that are allowing for ATP to be produced in your body or consumed. And this is just an example of the mitochondria, the one you should know, utilizing a lot of chemical processes within the body. 3 down. 2 more. Give me a thumbs up. We good? Okay, majority rules. We're going. So analytical chemistry is the 4th branch of chemistry. And physical chemistry is the 5th branch. So analytical kind of sounds like the word what? Analyze. So it means you're really getting nitpicky here, and you're looking at the details, and you're looking in depth at, in this case, composition of matter. And that means that you're looking at, what's the percent carbon, what's the percent hydrogen, what's the percent oxygen. And when you do that, it gives you a lot of information about what that compound could be used for or how it could be manufactured. This is just an idea of what could fall under analytical chemistry. What they do is they can shoot a small sample of matter, different ions, through a little device, and when it does it, it fragments it and it breaks it up, and when it fragments, it hits different parts of a sensor, and the fat things hit one part of the sensor and the light things hit another part of the sensor, and it gives them an idea of the composition of a given sample. So they could do that with some drugs they find on the street and say, well, this sample resembles a sample we found in Texas, not right now because everybody's having a bad time in Texas, but they definitely would be able to compare and contrast the composition of different types of powders they could find and then narrow down where things came from. And that's actually called mass spectra. They're looking at the mass of something. Lastly, we've got physical chemistry. Physical chemistry is talking about the physical properties of a lot of every compound. Things like melting point, freezing point, boiling point. Those are some properties it could investigate. It also is going to talk about the changes that are taking place when reactions occur. Looking at this example here, this is actually a reaction taking place, and instead of tracking the chemical compounds, they're tracking the energy. So they're looking at the energy of the reactants initially, and they're looking at the energy of the products at the end. What do you notice about the energy from here to here? It got lower. Okay, so that's easy observation straight from a graph. So if you were to feel this reaction happening, you would actually feel something because this reaction released energy. And if you're holding onto a beaker and it's, you got this high amount of energy, and then at the end when the products have been made, there's a lower amount of energy, where do you think that energy went? Say again? Just released into the air, but what if you're holding that beaker? Well, you're holding that beaker, right? So can't energy, heat, for example, move through a beaker? it easily could, like a coffee cup or another container. So it actually would move to your hand and would feel warm to you. Sometimes that's beneficial. We need that. The opposite of that would be an endothermic reaction, but this is an exothermic reaction. So that's our 5 branches, okay? So that's just in a nutshell, kind of chapter 1, and then in chapter 1 it elaborates a little bit more on each of these. Okay, we're going to switch modes to a safety exercise, okay? So pay attention because I'm going to give you the instructions quickly. Oh, before I do that, I want you guys to turn and talk. You got 2 minutes. I want you guys to write down as many things you can think of that relates to chemistry in your life. 2 things. Just 2. You have less than 2 minutes now. One from each of you, or 15 of them. Write down as many, 2 minutes, but as many things you can think of that relates to chemistry in life.
We should really need to.
Said you got 2 minutes. Write down as many as you can think of. Somebody said 2, and I said yeah, and I was like, no, that's not what I said. I'm just trying to think of All right, now I want you to share it with somebody else. So take your paper and turn around or scooch to the side and share with somebody else the things you came up with. When you first see your topic, you halfway. Alright, does anybody want to share? I might get like trivia to share a really interesting or unique example of what you came up with. I could do random calls because fun. You want to volunteer? Yes, ma'am. Hallie. Say again?
Baking.
Baking, 100% chemistry. So I used to work at a catering service that also was a bakery, and they would sometimes let me bake cookies and brownies, but most of the time I was just the girl taking the orders and going to cater for like baby showers and wedding showers. It was great. I got big tips, like $100 tips. You guys should get in that business. But my boss lady was a chemist, and she ran the catering business. She's like, yeah, I just decided to use it all for baking. I was like, this is great. This is awesome. Yes, sir, Evan.
Transportation.
Transportation. What do you mean specifically? Give me something better.
Like the fuel goes into the engine, and the engine causes a reaction which powers the car forward.
Right, and so the engine can also be driven by not just, fuel is a good generic term because it gives us a lot of opportunities to use many things there. But think like Tesla, think of our cars that are soon going to be in our hands, and unless you didn't get on the list, it's a long waiting list, but you can get a Tesla and it's an electric car and you have a battery and that would be your fuel, which is just spent electrons. One more. Yes, ma'am. Yeah, cleaning supplies they have ammonia. You guys know what ammonia is? Yeah. Okay, you know it smells like cat pee, right? Cat pee is ammonia. And ammonia is what you clean your house with. Okay? But don't clean your house with cat pee. It'd be gross. But it's not quite the same thing. But yeah, so cleaning supplies can 100% either corrode and erode something, or they make it just a perfect recipe so that it doesn't basically ruin your countertops and floors and desktops and things like that. So they have to be a healthy recipe so that it's not going to be too corrosive. But very good cleaner. That's what laundry detergent and everything else does. If not, it would eat your clothes away. Okay, now we're switching modes to safety. Okay, so the idea is that I'm gonna put you in a situation where you have to look at some data, and that data is going to be kind of a collaborative action because not everybody can look at 6 pieces of paper at the same time. So we're going to have to divide and conquer some, but I still want you to collaborate. How is cooperation different than collaboration? Rhetorical question. I'm going to answer that. Cooperation is where you're just like, okay, you do this, I'll do this, and then okay, go team, and then we'll go do our own thing and we'll come back. And we kind of talk to each other at the end, but it's more like, hey, I'll copy your paper, you copy my paper, and we'll just turn it in. That's like you're getting together and you're getting the job done, but sometimes that doesn't really fuel the teamwork that needs to be happening to really learn what you need to learn. Collaboration is you still can divide and conquer some, but when you come back together, you're still teaching each other and really elaborating and getting the details of what you discovered so that everybody learns what you learned versus just copying someone else's paper. You got it? Collaboration. Cooperation-ish, but collaboration is what I'm looking for. So when you guys go back in lab groups, I'll tell you guys those in a second. Here's your scenario, okay? The goal is that you're going to be given some chemicals and you can choose what's going to be your couple of chemicals that you'll choose. I have it listed back there for you. And you're going to arrange them safely in a storage closet. I have to do this every year, and then when you go through that back room, I have a big storage closet, and there's 200 plus chemicals back there, and they have to be there safely so that they don't explode. So your role is that you're a safety officer in like a factory. It can be anywhere. Anything that's chemicals would have a safety officer. The audience, or who this would be given to, would be the OSHA inspector, someone who's coming in to vet you and say, are you doing the right thing? Are you putting chemicals in the right place? And are you going to try to avoid any catastrophes in your factory? The situation is they're coming to see you. You need to provide them with a chemical inventory and a diagram of a closet with where you're putting your chemicals. Because as you can imagine, would you want to put flammable things next to something that's easily going to catch on fire as well? Or would you want to, let's do it this way. Would you want to put chemicals that are flammable near something that would be like an ignition source? No. OSHA would be very angry with you. But what you want to think about is, how are these properties similar? How are the properties different? And how can I arrange my little chemical storage closet to resemble what would be a safe environment? So in preparation, you'll give a presentation to your supervisors explaining the importance of the chemical handling for your safety and inspection score. So this sounds elaborate, but I'll tell you what you basically need to do. When you get your chemicals, and you'll have a list you can choose from, you'll first choose your chemicals, and then you're going to, in the end, provide a diagram of a storage closet, and then also why you placed it where. So let me give you a quick example. So your storage closet can be literally shelves, 3 shelves. That might work, it may not, depends on what your properties are. Your storage shelves could also be separated. You can have like a little extra container down here, maybe for something that's super special and it's on the corner. You can make a whole entire room set off to the side with like a lock on the door. This is supposed to be a lock on the door. Lock, okay? Maybe because it's a different type of chemical that would be maybe a little bit more hazardous. Within that thought, you're going to make sure that you look up some of the details about those chemicals, and this is what you have here. And at the very, very end, and we should have time for this, I'd like for you guys to look up a real-life scenario where maybe somebody wasn't considering chemical safety and there was an accident. You guys will find plenty of them. There were plenty in schools as well, which is sad. But at your lab station, this is what you'll see. You'll have 4 categories of chemicals. They all they're dispersed. They've got some random ones here. But you have to pick at least 1 per category, but 6 overall chemicals. Got it? Okay, everyone's going to be choosing different things. And also back there, you guys have some extra information about safety. But after you make your list, you're going to try to design a closet diagram based on properties of these chemicals that you find. Well, you're supposed to be asking now, where the heck am I going to find these properties? Basically, every single chemical has something called an MSDS sheet, Material Data Safety Sheet, and you can look them up online. So if you, and I just pulled this one for example, but for sodium, you guys know sodium. What's the chemical symbol for sodium? Na, that's S is sulfur. But we're getting there. So here's what I said to do, and I put it up here so you guys would remember. Section 8 and Section 10 of this big sheet has really great information, specific information for this activity. Oops. So I'm going to just show you first. The Section 1 kind of gives you just some basic information, chemical name, sodium, and so forth. And then 2 tells you about the composition. 3 tells you about some hazards. 4, safety measures, a lot of safety measures. 5 is kind of interesting. Sodium by itself is flammable. Did you guys know that? When you put sodium metal, it's a little like piece of silvery metal, put it in water, it catches the water on fire. Okay? I don't have sodium. I'm not allowed to have sodium. I would get in trouble if I had sodium. OSHA would tell me I couldn't have it. True because I've had it before. And yeah, so you guys can see that section. Handling and storage, and then Section 8 talks about like personal protection, what would be good to know about safety. Section 9 is a really good section too because it gives you information about just all the physical properties of the compound. And then Section 10 See where it says stability and reactivity? It'll tell you what it could possibly react with. So would you want to put two things together that would react together? Maybe not, because then we would have an explosion. And that's not our goal, okay? Not our goal. Might be your goal, but not my goal. So you guys can see that there. So that's called an MSDS sheet, okay? And other than that, I'm not going to do the intro to something fun about yourself. You guys can do that later. Orally review the lab equipment. We kind of did that yesterday, so I feel like you guys are okay. So I'm going to tell you where your laptops are. You guys are numbered. You guys have probably done this before. You get a number for the laptop, so you do the same one every time. Each top system is complete. So I'm showing you this here now. You get your laptop numbers here. It's out order, so one over there. One of you guys are going to 29. There are 30 laptops in here. So, you know, I probably must see everybody get a laptop. You guys can have desktops there. And then you guys are going to start to do that how to avoid an explosion activity, which is at your desk. Any questions right now, guys? I know you'll ask me questions when you get back there. Okay, let me show you your lab stations. So this is the first time we're doing lab stations. This is not your class. And I use a randomizer. I don't play favorites, so if you want to buddy up with somebody, I might I'll allow you to choose groups at one point in time, but right now I have 9 lab groups, and I'll tell you kind of how they are arranged in the lab. You guys want a pencil, you want a piece of paper, that would probably be beneficial. And then look back here, you see the little numbers, they're kind of hard to see down here. This is lab station 1, the other half of this is lab station 2. And then this is lab station 3, and the other half of this is lab station 4. Lab 5, you get a whole station to yourself. Okay, lab station 6, lab station 7, lab station 8, and then lab station 9. What I might do is 9, because who are here 9 and got a laptop card there, I'll just push you over here. Okay, sure. You just want to grab your laptop. I ain't the only one. Listen to me.